Good afternoon, it's Lee Cassidy from Tactile Technology, and I'm going to talk to you about a technology we've worked with and we love and worked with for many years, which is Tintri. So we've been working with Tintri for around about 10 or 12 years now, since they first came to the UK. And if you're not aware, Tintri actually means lightning in Gaelic. So it's an interesting technology. And it was one of the first that was introduced that was focused purely at delivering infrastructure for virtualized environments rather than using existing storage mechanisms that people were utilizing, like block mode storage or file mode storage. This was specifically designed for that environment. So what I want to do is start off with a presentation. So just go through a few different slides with you, just to give you a picture of what we can do with it. I'm talking about the EC6000 because I'm going to demonstrate an EC6000 directly, because we've got a 6000 series in our data center, which is an all-flash array. It's a 2U rack mount unit, so quite small as well. But also I'm going to talk a little bit about some stats for the new T7000 NVMe-based system as well, so give you some ideas and some comparisons of that. So starting off, we're going to cover a little bit about the family, some idea of configurations and some of the options, how it can actually be expanded as well as the capacity you get from them, and then finally talking about a bit about performance and giving a quick demo of the system so you can see what it looks like. So first of all, the EC6000 series, it was one of the first hybrid systems prior to it being an all-flash platform, and it gives you all-flash array inside, so it's completely flash, all SSD based. It actually works with any of the workflows you might have, whether that's utilizing VMware, or you might have got something like Hyper-V. It'll work with either of those type of platforms. And there are four main models, starting with a system that will support around about 500 virtual machines, all the way up to about 7,500 with the EC6090 platform. These have got very high performance, starting at about 75,000 IOPS, going up to 320,000 IOPS. But the key thing is the throughput and the latency is extremely low, because you want really low latency for a virtualized environment. It doesn't really matter about IOPS, really. It's just a lot of people compare storage systems by IOPS. So at least it gives you an example of where you could be. From a usable capacity perspective, you start at one end between 4 and 16 terabytes, up to the other end between 15 and 130 terabytes, depending on how much has been put in there. But the actual effective capacity is much higher than that, because you get dedupe and compression. So you'd normally be looking at 1.5 times for the compression, and anything up to 5 times for the deduplication, depending on the type of workloads. So it varies depending on what you're actually running on it. But you're going to get anything from 19 to 645 terabytes of effective capacity from one of these units. The unit itself, it looks quite straightforward. Rack mount unit. You can see all the dry bays on the front. It does have a pretty bezel to cover the front over as well. Power button to turn the thing on, and you've also can see some details about which controllers actually active A or B when it's running. Looking at the back, we've got independent power supplies. So we've got 2 in there just in case one fails, it'll pass over to the other. But we've also got 2 separate controllers as well. So each of the controllers can run the system independent of the other. And in there, we've got a number of data ports. These data ports can be anything from 1 gig through to 40 gig options. And I'll cover some of those off in a second. We've also got replication ports. So if you're looking to do synchronous replication, you can actually connect units together with replication ports to actually give you synchronous replication if you want that automatic failover capability you see with a lot of the enterprise class systems. Also administrative ports, 1 gig to be able to manage the system. There's a VGA port for a KVM connection, so you can actually manage it locally and just do initial setup. There's also a couple of USB ports, again, for the KVM access for something like a keyboard and a mouse. And you've also got a remote management port as well. There are also some other 10 gig ports that can be assigned for things like data or replication that are built-in ports as well. So some of the options, most people go for a 10 gig connectivity using SFP+, but you can go all the way up to 40 gig QSFP if you need the performance for it. The actual drives are set out as a RAID group 6, a majority of them, so up to 21 drives if it's fully populated. It could be less than that if you've actually got it partially populated. It would be 10 plus 2 plus 1. But also you've got on top of that a mirror pair, which are tied to each controller to give that extra RAID 10 capability. So you've got an extra copy of the data just in case there is a failure. Plus there's a hot spare running as well in the background. Easily fitted into a rack. All you need is the rails fitted, standard ones to a standard rack. Once they're fitted, a couple of screws, you can slide the unit in and it's well supported. The capacity expansion depends on which unit you buy and how much you actually populate it to start with. So most of the units can be half populated and then additional drives added to them to increase the capacity. So if we got a half populated drive, there is actually an expansion estimator that's built into the application. So what you can do is go on there and adjust it to get a picture of how much additional capacity you get depending on how many drives you add into it. So at the moment we can see there we've got 24.6 terabytes used, we've got 6.2 terabytes of free, and the total capacity at the moment is 30.8, and we're getting a space saving of about 5.5 times. So that's what we're getting, with that both compression and dedupe capability. If we expand the actual drive capacity, it will actually show us how much additional capacity we'll have. So we can actually see that growing and how many drives we'd need to actually increase that capacity. So as we move up, we'll see again how many more drives and how much additional capacity that it will generate for us. What I'm going to do now is give you a quick demo of the system. So I'm going to just jump over to my demo system. I'm going to be looking over this side at times because I need to see that to be able to do this. I'm just going to try and drop out of PowerPoint. So quit my PowerPoint demo and then go over to my live system, which is on a web browser. So I'm just going to get my web browser up in front of me. And we can see the actual VMstore here. So we can see the general interface, which is the overview page to start with, giving us the amount of capacity that we can actually go to. So we've got the lowest we've ever gone IOPS-wise with this system. It is a demo system in our data center, but we have some workloads active on it. It's 187 IOPS, but we've been up to 12,817 IOPS as well with this particular system. But again, it can actually be driven much further than that. We can also see throughput figures. We're seeing throughput of around about 6.9 megabytes at the moment, but we've gone anything from 2.7 to 472.5 megabytes through it. These are 10 gig connected over multiple connections, so we can go to quite large amounts of throughput. We can also see latency figures. So our average latency is 0.2 of a millisecond, so very low latency on this system. Like I said before, in a virtualized environment, latency is more important, getting low latency than it is IOPS. But a lot of people need to know IOPS to be able to compare it to additional other types of systems. Because if you're measuring it and comparing it against something like a traditional block mode or something like a file-based system, you really need to be able to try and compare the two from an IOPS perspective. And that's all the figures are there for. These are two really important pieces. One of them is the performance reserves. So it's showing us on the left how much of the performance reserves are actually being utilized. So we're actually using a very small amount of it, around about 19%, and 80% of our performance is free. That means we can actually load this up with nearly 5 times as much workload that we've actually got on it at the moment and still be within the capabilities of the controllers from a performance perspective. Looking at the bottom, we can see the physical space, so how much we're utilizing. So at the moment, we're using around about 5254 gigabytes of of actual space, and we've actually got 81.54%, so quite a large amount of space free still. So we can see how much is provisioned in this system, how much is used, how much is free, and the total amount. And at the moment, we're getting space savings of 1.71, because a lot of the data that we've got on this system is not compressible. A lot of things like video data and images that are already compressed, so they won't compress anymore. So if we had other types of data, traditional data, again, it could go up to around about 5 times. If you're doing something like VDI workloads, you can get up to 10 times, the actual dedupe on them, because a lot of file data is very similar. The other thing we can see on the screen on the right-hand side is the performance reserve changes and the space changes. So the top is which of the actual workloads on this system are actually using more performance than they did before. And it's giving us a picture of how much they've gone up or gone down recently. Below that, we've got from a space perspective, so we can see how much they've increased or decreased in the amount of space that they're utilizing on there. So quite easy to understand if a system, a particular virtual machine is starting to use more capacity or starting to take up a lot more space. We can see that quite quickly from that image on the right side. The other thing we can do is look at some of the metrics, and this is for the actual box itself. So we're not looking at any particular virtual machine independently at this point. We're just looking at the whole of the machine and what we've seen from a real-time perspective over on the right-hand side here of IOPS. And under that, we've got IOPS and normalized IOPS, so comparing the two. But we can add other things in there. So if we wanted to look at, say, throughput and latency on there, we could actually add those, and we can see those bits of information again straight away. And this is using HTML5, so it works on any type of device. There's no flash or anything required to do this. And again, we can have a look and see what's happening. When we look at the latency, we also see it across the board, not just what's happening from a storage perspective. So how much time is it taking to read or write data from the drives within the array? It also gives us a picture of the amount of delay or latency in the network, so the time it takes for the network to actually transmit that data between the storage system, this array, and the compute platform. In our case, it's a number of Dell blade servers in there, so we can see the latency there, and on there we can actually see the figure at the point in time we're looking at the graph. So very low at the moment. Network is 0.1 of a millisecond on there. We can also see host as well, and you can actually dig down into that detail even more on the host side. So you can look at it from a CPU, memory, and also swap piece as well. A lot of you might think, what's important about that? But how many times have you been in a situation where you couldn't work out where the problem lied? You've got an application that's running slowly, but you don't understand where in the actual infrastructure the problem is. Whether it's actually at the storage end, if it's in the network, or on the compute side, where is the problem? Where is that latency being generated? And with this spike here, we can see it's host generated. So we know that's on the compute side. So we can actually focus our efforts at looking in the right area. But like I said, this is purely looking at the array itself, not at any particular workload. So what we can do at the top here is we can select managed objects, and again we can look at a number of things. And on here we have some of these figures talking about what's happening for that particular host. So this is a SQL server, and we can see there's very low host and network latency and a small amount of storage latency, very, very low for this system. But if we wanted to look a bit more in depth on that particular one, we can actually go into that particular virtual machine. So now we're looking at it specifically for that virtual machine, and we can see some overview figures. So how many IOPS is it using at the moment, what throughput or latency we're receiving, how much physical space has been utilized, and how much has been provisioned for this particular server. We can also then look at metrics for this particular server, and we can see some of the figures across the top here. But we can actually look over different periods of time. We might want to look at 8 hours or 4 hours, or even just the last hour and see what's happened. So we'll look at 4 hours, And at this point in time, we can actually see what was happening with that particular machine. We can expand that out. If we want to look over a larger period of time, we can slide this around and look for particular peaks and troughs of activity. So it could be one of your users has said, things were quite sluggy with the application at a particular point in time on a particular day. So what we can do is go to that particular day and look for that spike in latency. And then what we can do is have a look and see what was creating that latency. Was it read-write activity on the storage? Was it something like latency, to do with the actual CPU network or something else? And we can, add in different bits of information to give us a picture of what's happening on that system. So if we look down here at this particular point in time, again, we can see how much of the latency was related to the host, how much to the network, how much to the storage. So it makes it much easier for us to diagnose what was happening with that particular virtual machine. We can also look at snapshots. So at the moment with this one, we do an hourly snapshot. So we've got every hour we can recover to a single point at the same point. And those snapshots can be recovered in a few seconds. It's really quick to recover. It just changes the mount point within VMware for that particular virtual machine, and you're effectively up and running very, very quickly. We can also clone any of these. So any of these snapshots, we can actually clone and create another machine from that clone. So if you were doing something like testing of a particular application or patching even, what you can do is clone the virtual machine, change the configuration for the network or disable the network for it. And then you could bring up that clone and actually test some patching or a new application or even new data against an application with it. We not only can actually do this at the actual virtual machine level, we can also do it at the disk level. So we can actually go into a particular virtual machine and look at the disks that that particular virtual machine is utilizing. And again, we've got activities around metrics for the virtual disk for that machine rather than the virtual machine itself. So we can see each of those individual virtual disks and the metrics that are happening for it. So hopefully this has given you a bit of a picture of how things can be done much simpler in deploying virtual machines in a VMware or Hyper-V environment. One thing just to give you a bit of clarification is this just looks like one big lump of storage. So however much storage there is, it looks like one big lump. So you just create a data store and give that to the vSphere environment. So you go into your vCenter, add in that lump of storage, and then you can just utilize it. You don't need to think about LUNs. You don't need to think about particular storage groups that have been created within an array. It's just one big lump of storage. And the other thing inside the actual software, it's also going to manage things like quality of service automatically. So it's going to ensure that you're getting the best performance for each virtual machine. And it does also virtual machine separation for performance. So what it does, it looks at what the normal use of resources is for each virtual machine, and it gives each machine a good amount of capacity, which means that if another virtual machine starts to try and utilize much more of the resources on the platform, so reading more disk, using more CPU within the controllers, it'll actually stop that happening, so you don't get that noisy neighbor syndrome that might happen when you're doing mixed workloads, something like VDI against a traditional server and maybe some database workloads. This will ensure you don't get that problem. It controls that. One thing I did go through on a slide earlier was how you can actually expand the capacity. So if I click on the hardware here, it's going to bring up a picture of the hardware, and we can see how healthy it is, what's happening with it, some statistics. We can look at temperature and fans, everything looking okay on there. All the network components are running fine. So we know everything's running and working fine. But what we can also do is this expansion estimator. So we can have a quick look in here and we can see that our particular unit is half populated. So it's got half the drives with those additional ones for the mirror in there as well, and also the spare. So if I decided I wanted to add in, say, another 4 drives, I can see how much, in fact 5 drives in this case, it'll show me how much additional capacity I'll gain from that. In fact, I can go all the way to the top and say, if I fully populate it, what additional capacity will I get? So we've got, get current against planned, and we can actually give you a good understanding of how much additional capacity you'll get by adding in those drives. Much easier to buy a half-populated larger array and then add in this later. It's much more cost-effective and granular. Plus, it's also a non-disruptive process. All you do is put the drive in and then go to the interface and say add additional drives, and it's not seen. You don't see any delay. All that happens is the amount of capacity increases on that data store, and you've got those extra drives added into the total amount. So really, really simple, to increase the amount of capacity, but also you're increasing the amount of performance reserves because you've got more drives sharing the workload as well as the controllers. So hopefully that's given you a good picture of what you can actually do with one of these systems. I'm going to drop back to my main presentation now. And so hopefully that's given you a bit of an idea about what you can do with the Tintri VMstore. I've got a couple of metrics here to give you on the T7000 series. So at the low end of the low model, we're looking, which is a T704 7040, you're looking at the ability to run around about 2,500 virtual machines a maximum, and go up to the top end system, which is a 7080, you're looking at 7,500 virtual machines on a single array. So very, very dense storage for virtual machines. The amount of virtual disks, bottom end you're looking at 7,500, top end you're looking at 22,500 virtual disks that you can have in that. So each of your virtual machines can have much more virtual disks if you choose to. You can have very, very high throughput as well. But one of the key things you get with this is the ability to run 100 gig Ethernet if you want to. So you get no latency on the network at all. So really good throughput for it. So an extremely performant and also dense populated platform. But from my perspective, one of the key things with it is the amount of work that needs to be done. Our system runs in our data center. We may look at it for demo purposes like we've done today. We may look at it from time to time, but to actually go in there and actually do any configuration changes or anything, we actually do less than 10 minutes a month of actual work with the storage platform. And if you consider your storage platform, whether that be a block or a file-based storage system, I'm sure you actually spend more time than 10 minutes a month looking after your storage and enhancing it to make sure that you're getting the right performance with tuning things to get your virtual machines operating at the best level. This is completely automated. It does all of the work itself. You don't need to do anything. Well, thank you very much for joining me today. It's quite a short one. I've got another one next week, and I've got Ross Cooper-Smith with me next Wednesday to look at the alternative Tintri platform, because Tintri have also got a block and file-based platform called IntelliFlash. And again, they've got NVMe-based products that have just been released, and also some very large-scale products as well that you can use for very large, data store, data lake type capacity as well. So we'll have Ross Cooper-Smith on next Wednesday to go through that. So hopefully you can join me then. If you are interested in anything that I've covered today, I'll just put some details at the bottom. So if you are interested in what we've seen, or you'd like to have a personalized demo, you can contact myself, Lee Cassidy, or Rachel Gould. Emails are at the bottom, and let us know what you'd like to look at, and we can give you a personalized view and a presentation specific to your use case. So whether that's a traditional virtualized environment, or whether actually you're starting to go down the Tanzu or something similar piece where you actually want want containerized workloads and you're looking for that high level of performance for the storage that's behind it, again, we can actually show that with this system. And again, all those stats like latency, throughput, figures and things we can actually show you, so you can actually see where there are issues. When people are starting to use, especially hypervisors, to deliver containerized workloads, it can be a challenge to understand where the problems are. With this, it makes it much easier to understand, where the problems lie and to be able to deal with it quickly. And again, from a testing perspective, much easier to be able to spin up workloads and manage those as well more effectively. So thank you very much for your time today. Like I say, let me know if there's any questions about it. I'll put some comments into the LinkedIn post as well, so you can have a look at that and let me know what you think. And hopefully we'll see you soon. Next week, we've got a In the Hot Seat on Tuesday, and we've also got Ross Cooper Smith Wednesday, and also a second In the Hot Seat on Thursday for you to see. So hopefully we'll see you soon. Thank you very much.